As the global population ages, age-related health issues like mild cognitive impairment (MCI) and sarcopenia are becoming increasingly common. MCI affects memory and thinking skills, while sarcopenia involves the gradual loss of muscle mass and strength. These conditions not only impact daily living but also increase healthcare costs and reduce quality of life for millions of older adults. Interestingly, research shows that MCI and sarcopenia often occur together, suggesting that the health of our brains and muscles are more connected than we once thought. Understanding this connection is crucial for developing strategies that help older adults maintain independence and well-being as they age. Mild cognitive impairment, or MCI, is a stage between normal aging and dementia. People with MCI may notice memory problems or difficulties with thinking, but these changes aren't severe enough to interfere with daily life. MCI can affect different cognitive domains such as language, attention, and executive function. There are two main types: amnestic MCI, which mainly impacts memory and is often a precursor to Alzheimer's disease, and non-amnestic MCI, which affects other thinking skills and may lead to different forms of dementia. Recognizing MCI early is important because it represents a window of opportunity for intervention before more serious decline occurs. Sarcopenia is the progressive loss of skeletal muscle mass, strength, and function that occurs with aging. It can be caused by age-related changes or underlying diseases. Sarcopenia not only makes daily activities harder but also increases the risk of falls, frailty, and loss of independence. Recent studies have shown that sarcopenia and MCI often appear together, and each can worsen the other. This highlights the need for strategies that address both muscle and brain health in older adults, aiming to preserve mobility, cognition, and overall quality of life. Emerging research reveals a fascinating connection between our muscles and our brains. Skeletal muscle acts as an endocrine organ, releasing signaling molecules called myokines during exercise. These myokines travel through the bloodstream and can influence brain health, supporting processes like neuroplasticity, memory, and learning. For example, exercise-induced myokines such as BDNF and IGF-1 play crucial roles in promoting neuron growth and protecting against cognitive decline. This crosstalk means that keeping our muscles healthy through physical activity can directly benefit our brains, especially as we age. Resistance exercise training, or RET, involves activities that make your muscles work against a force, such as lifting weights or using resistance bands. RET is well known for building muscle strength and mass, but its benefits go far beyond the gym. Recent evidence shows that RET can also improve cognitive performance, reduce inflammation, and even protect brain structure in older adults. By activating key molecular pathways, RET helps maintain both muscle and brain health, making it a powerful tool in the fight against age-related decline. The molecular level, RET activates anabolic pathways like Pi3K/ACT/mTOR, which are essential for muscle growth and repair. These pathways also stimulate the release of neurotrophic factors such as BDNF, NT3, and IGF-1, which support brain health by promoting neurogenesis and synaptic plasticity. RET-induced myokines like irisin and cathepsin B further enhance these effects, helping to maintain healthy communication between muscles and the brain. This molecular synergy explains why RET is so effective at addressing both physical and cognitive aspects of aging. Neuroinflammation is a key factor in the progression of cognitive impairment and dementia. RET has been shown to modulate the immune environment in the brain by shifting microglia, the brain's innate immune cells, toward an anti-inflammatory state. This reduces harmful inflammation and supports neuronal survival. RET also helps astrocytes, another type of brain cell, adopt neuroprotective roles. By reducing neuroinflammation, RET not only protects brain cells but also helps preserve cognitive function in older adults. Structural changes in the brain, such as loss of gray matter and reduced hippocampal volume, are common in MCI and dementia. Neuroimaging studies have shown that RET can help preserve brain structure, particularly in regions like the hippocampus and precuneus, which are vital for memory and executive function. RET also improves white matter connectivity, supporting efficient communication between different brain regions. These structural benefits may help delay the progression from MCI to more severe forms of cognitive decline. It is not just about building muscle, it also has powerful effects on the mind. Clinical studies have found that RET can significantly improve executive function, memory, and overall cognitive performance in older adults with MCI. These improvements are not short-lived. In some studies, the benefits of RET on cognition have lasted for up to 18 months after the intervention. This makes RET a promising strategy for maintaining mental sharpness and independence as we age. While aerobic exercise has long been recommended for brain health, RET offers unique advantages. Unlike aerobic training, RET specifically targets muscle anabolism and myokine release, which are linked to both muscle and brain benefits. Some studies suggest that RET may have even greater effects on global cognition than aerobic or multimodal training. By combining RET with other exercise forms, older adults can maximize their physical and cognitive health. Myokines are signaling proteins released by muscles during exercise, and they play a key role in the muscle-brain connection. RET increases the production of myokines like BDNF, IGF-1, irisin, and cathepsin B. These molecules cross the blood-brain barrier and support processes such as neurogenesis, synaptic plasticity, and memory formation. By boosting myokine levels, RET helps maintain both muscle and brain health, offering a holistic approach to healthy aging. Glial cells, including microglia and astrocytes, are essential for brain health. RET influences these cells by promoting anti-inflammatory and neuroprotective phenotypes. For example, RET encourages microglia to adopt the M2 anti-inflammatory state and astrocytes to shift toward the A2 neuroprotective type. This cellular shift helps reduce neuroinflammation, supports tissue repair, and maintains a healthy environment for neurons, all of which are crucial for preventing cognitive decline. Oligodendrocytes are the cells responsible for forming myelin, the protective sheath around nerve fibers. RET stimulate the differentiation of oligodendrocyte precursor cells, enhancing myelin synthesis and repair. This is vital for maintaining fast and efficient communication between neurons. RET also protects oligodendrocytes from inflammation and oxidative stress, further supporting brain health and resilience against neurodegenerative changes. Advanced imaging techniques like MRI have provided direct evidence of RET's benefits on brain structure. Studies show that RET can preserve or even increase hippocampal volume, maintain gray matter density in the precunas, and improve white matter integrity in older adults with MCI. These structural changes are closely linked to better memory and executive function, highlighting the real, measurable impact of RET on the aging brain. White matter hyperintensities, WMH, are common in MCI and are associated with cognitive decline. RET has been shown to improve white matter integrity, particularly in key structures like the corpus callosum. By enhancing white matter health, RET supports better communication between brain regions, which is essential for complex thinking, memory, and decision-making. These findings further support RET's role in protecting the aging brain. Clinical trials have demonstrated that RET can significantly enhance memory function in older adults with MCI. Improvements have been observed in tests of episodic memory, verbal learning, and delayed recall. These cognitive gains are linked to RET's effects on brain structure and neuroplasticity, as well as its ability to reduce inflammation and support healthy brain cell function. For many older adults, these improvements mean a better quality of life and greater independence. Executive function includes skills like planning, decision-making, and flexible thinking. RET has been shown to improve these abilities in older adults with MCI, with benefits lasting well beyond the training period. Enhanced executive function supports daily living, problem-solving, and social engagement, making RET a valuable intervention for maintaining independence and mental agility in later life. Maximize the benefits of RET. It's important to follow evidence-based protocols. Studies suggest that training 2 or more times per week, with sessions lasting over 60 minutes, yields the best results for cognitive and muscle health. Exercises should target major muscle groups and be adjusted for individual ability and safety. Consulting with healthcare or fitness professionals can help tailor a program that's both effective and enjoyable. RET stands out as a dual-action intervention that addresses both sarcopenia and MCI. By simultaneously improving muscle strength and cognitive function, RET helps older adults maintain mobility, independence, and mental sharpness. Its effects are supported by robust molecular, cellular, and clinical evidence, making it a cornerstone of healthy aging strategies. While the benefits of RET are clear, there are still questions to answer. More research is needed to standardize RET protocols, determine the minimum effective dose, and identify biomarkers that predict who will benefit most. Longer-term studies with larger groups will help clarify how RET can be best integrated into dementia prevention strategies. Combining RET with other interventions like cognitive training or nutrition may further enhance its effects. Summary: resistance exercise training offers a promising, multifaceted approach to delaying cognitive and physical decline in older adults. By activating key molecular pathways, reducing neuroinflammation, and preserving brain structure, RET helps maintain both muscle and brain health. As research continues, RET is poised to become a central part of strategies aimed at promoting independence, quality of life, and healthy aging for years to come.